Board of Education.
Yeah.
Do you remember when we talked about standard deviation back in lesson 8.2? I told you that 68% of data falls within. Remember this?
Sure.
Does it sound familiar at all?
Oh, yeah.
68% of data falls within one standard deviation.
Yeah.
95% of data falls within. You've forgotten. Look in your notes. Open them up. Go to lesson 8.2.
It's hard for us to take you seriously.
Yeah. Can't see me. I'm right here.
No, because it was a sub.
Yeah.
A sub.
Yeah.
Oh, this was last Thursday?
Yeah.
Well, get your notes out anyway.
No,
So I had you write down some statistics, and it was it looked like this. You had a little line, and the average was right here. It was 74 point something, and we had all these X's. Is this looking familiar?
Yes, it is.
These are all the data points that are within one standard deviation. Because here was the mean, X bar, and that's one standard deviation. Anyway, it was something kind of like this. Here's 2 standard deviations and 3. This is looking a little more familiar now. Okay, because to make this lesson a little easier, you need to remember the facts. 68% of data within one standard deviation, 95% within 2, and 99.7% is within 3 standard deviations. So pretty much if you go out 3 standard deviations, you're going to cover all of the data, usually. 0.3, you know. So we actually need to draw a little bit of a better picture here, so I'm going to erase this. You need to draw this. So draw a line going this way. Then draw a dotted line right in the middle. Write this word because now you all know what it means. Get it? Actually, I didn't think about that, but yeah, nice. Draw a dotted line here, and draw another dotted line here. This represents +1 standard deviation. This here represents -1 standard deviation. So you add a standard deviation or you subtract a standard deviation. Okay. Draw another line out here. And another line out here. This represents +2 standard deviations. This represents -2 standard deviations. One more dotted line there. One more dotted line there. This represents +3 standard deviations. This represents -3. Okay, and do the best you can to copy this picture. That's what's called a normal curve. Or a normal distribution. 68% of data is within one standard deviation. I told you guys that, hopefully you remember it. But within one standard deviation can be +1 or it could be -1. Okay? So I'm going to put a 34% right here, and I'm going to put a 34% right here. What does that mean? What am I doing? What's 30? Why am I putting a 34 there? Am I just making up numbers?
So that's 68% in the first deviation.
You guys hear that? Whether you go +1 standard deviation or -1 standard deviation, aren't you within one standard deviation? And what should it equal? 68. And 34 plus 34 is 68. Okay? So, if I'm talking about just this region right here to the right side of the average, that represents 34% of the data. Or if I'm talking about this region, that represents 34. Okay? The entire region represents 68%. Okay? I'm going to put 13.5% right here. And 13.5% right there. And just so we're clear on the numbers, what is 13.5 plus 13.5?
26.27.
It's 27, huh? If you add 27 to the 68, so I've got the 68, and if I add another 27, what do I get? 95. So right now I've got 95% of the data within two standard deviations. To get to this, 99.7, we don't need much more. So this right here is 2.35%. And this little guy right down here, that's also 2.35%. You'll hear this phrase used in statistics classes, and even in college, when you get into college, they talk about the normal curve. This is what they're talking about. If data is distributed normally, it follows those basic guidelines. Okay. So these next three pictures don't have to be as detailed, but you've got that picture. You got that picture.
It's the first one is like
And you got that picture.
this one's centered, right?
Yeah. The first one should be centered right at the center. Sometimes your data doesn't follow a normal distribution. And you're not going to get into this in this lesson. This lesson deals with normally distributed data, but just so you're aware, not every data set follows this. So this will be normally distributed. This is what we're talking about today. Normal distribution. And if it is normally distributed, then these guidelines are true. Do you see how this picture is different, the one in the middle? Because the average would be right about here. So this is what's called positively skewed. The data is positively skewed. This one here would be negatively skewed. Okay. So you guys have books? You need books. Get books. You need books. Anyway, page, look at that, it is page 34. Page 34. Go to the problem. The problem one, got it? And you don't have a picture in your book.
saw his last.
Are we supposed to?
You're supposed to have there's no picture in your book. Is there? Oh, that's dumb.
There is. Oh, it's right here.
There's supposed to be pictures about bears, though.
Yeah. The brown bears.
The brown bears. All right, take a look up here. It's right here. And man, that's tiny. Do you guys see a magnifying button on here? I've never used this program.
It's right up there.
Express pull. You make this bigger. View.
Yeah, page is there.
Page zoom.
Oh,
No.
I did not.
You're supposed to be able to see this picture right here.
Oh, wait.
Everybody strain your eyes.
Look at that.
Yo. Yes. Come on, zoom.
Well, this is not working. I guess I put on here, but then it wouldn't show up on the video. Oh, wait a minute.
Oh my God.
Nice.
Okay, look at this picture right here. This bar graph gives the weights of a population of female brown bears. The red curve shows how the weights are normally distributed about the mean. Mean meaning average, right? It's 115 kilograms. Great, they're going all kilograms on us. Approximately what percent of female brown bears weigh between 100 and... So let's actually do this one before I have you do problem one, got it out of your book. This will kind of help you get ready. Approximately what percent of female brown bears weigh between 100 and 129 kilograms?
So, I want you to answer yes or no. Is this data normally distributed?
Yeah.
So look at your notes. What percent of data falls within what standard deviation? So, if we take a look at where our interval is, 120 to 129, isn't this our interval right here? Okay. The average was 115, so the average, 115 would be right here in the middle of this big giant bar. So 115.
How do you think we answer this? Thoughts?
Well, we could look at the normal curve and then match it with that. If you want.
Oh, one thing I need to have you write down that would make answering this easier. Go back to your notes. Exit full screen. This right here, that represents one standard deviation, right?
That needs to be about the halfway point of the normal curve. I'm talking about from the top of the normal curve down here to the bottom. The first standard deviation is about halfway. You follow what I'm saying? Okay, it's about halfway right there.
So now going back to this. Does that help make answering this question any easier? What are we thinking? Need to hear some thoughts. I can't tell what you're thinking unless you verbalize it.
Would it be 68%?
What population is between 100? Well, let's see. The question here is what percent of female brown bears weigh between 100 and 129? So here's 100 right here, and 129. This right here is actually just reading a bar graph.
What percent weigh between 100 and 109? What percent? 28. Are we saying 23? What percent weigh between 110 and 119? 42 maybe, I don't know, 42, let's say. So we said, what was it, 20,
23.
23, this one was 42, and now we're saying what percent
would lie between 120 and 129 kilograms. What does that look like? About 23. So if we add all these percentages up, what do we get? 23 plus 23 plus 40, what do we say this was? 42? Somebody add that up real quick. 23, 23, 42. 88%. Okay. So using this bar graph that's normally distributed, approximately what percent of female brown bears weigh between 100 and 129 kilograms? We're saying 88%. So now look at the problem one. Got it out of your book.
And actually, I want you to write this problem in your notes. Just write the sentence there. The problem one got it.
Part A, what percent weigh less than 100 and something?
120.
So use this bar graph right here on the screen to answer the problem one got it problem. Approximately what percent
of female brown bears weigh less than 120 kilograms? Don't say anything out loud, just write it in your notes. Take 30 seconds, talk about it with the person next to it. 30 seconds, go. What percent weigh less than 120? Okay, what answers do we get?
71.
70, 71. Is this group right here less than 120 kilograms? Okay, that's a cool color. What about this group right here? Ooh, missed that one. What about this group? All of those are less than 120 kilograms, right? So these represent percentages.
Oh wait, I forgot one down there at the bottom.
Can you guys even see that? There might be a little teeny one right here, maybe, possibly. Right there.
At any rate, this bar graph doesn't represent numbers, it represents percentages. And that's what the question was asking, what percent. So what percent does this middle one represent? 42. This one? 23. This one here? 5. And if you can see it, that looks maybe 1%, I don't know. So if you add 42, 23, 5, and possibly that little 1 there at the end, what percentage are we talking about?
71%. Okay. Or I would take a 70. Now the part B we're going to do together. Look at part B of the problem one got it.
The standard deviation of the female brown bears, blah, 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 is about
10 kilograms.
10 kilograms. Okay.
What percent are within 1.5 standard deviations of the mean?
Okay. So, would you guys feel okay if I said the mean is right here?
Yeah.
At 150? Isn't what I'm going to say the mean is 115?
Yeah.
Okay. So then, what did they say the standard deviation was?
10 kilograms.
10. So if I add 10 to the average of 115, what am I going to get? Come on,
125.
So 125 would be right here. So this is plus 1. You guys are right with that? That's plus 1 standard deviation. Then minus 1 would be Right here, remember how I said a few moments ago that +1 and -1 should be right about halfway this curve right through here? Okay, so there's +1 standard deviation. Okay, here's +2, and here's -2. Now you're right, they're asking for 1.5 standard deviations. So from here to here, that's 1 standard deviation, right? And then from here to here would be 1.5. And then same thing in the other direction. From here to here is 1 standard deviation, and then from there to there is half. So essentially, what are they asking? 1.5 standard deviations? Isn't that just these right here? Did we already answer that question? What percent of the female brown bears fall within 1.5 standard deviations? 88%. 88. Because if you had 23 and 23 and 42, you get 88%.
Okay. Alright. Let's get back to this. A lot of the stuff you just aren't going to be able to draw. That you just have to look at the pictures.
Don't you have the ISO?
Oh, you do have this one?
Yeah.
Oh, good.
That's oh yes, you do. Okay, look at the A practice problem then. It's on page 36. Look at the A practice on page 36. It looks like this right here on the screen. Look at these questions. Try to answer them real quick. We've got to do this problem plus one more, and then I think we're about done. So let's keep it going pretty quick here. Bless you. Yeah, he was. Okay. Question 1, about what percent? So yes, it says about what percent. So you got to understand that they're okay with some estimating going on here. So between 69 and 71, well here's 69 right here. And here's 71. So what would we do to answer this question? It really isn't as hard as it seems.
Add them up.
You add them up. What percent does this bar represent?
14.
Maybe 15 or 16 or maybe 14. Again, they're saying approximately. So what should we call this? 15? What does this represent?
16.
The mean.
Maybe 6. It represents the average, the mean, yeah. And
I got 14.
maybe 14. So we've got, come on now, there we go. 14 and 16 makes 30. 30 plus 15. So what percent would we say is between 69 and 71 inches tall?
45.
Roughly 45%?
44.
Okay, or 44, 46, somewhere in that range.
So as long as it's approximate, then it's fine.
Okay. Now this is where we start talking numbers. Let's say that this survey represented 100 men. So of those 100 men, how many would we expect to be between 69 and 71 inches tall? The answer to number 1, about 45 men. Right? The mean of the data is 70, and the standard deviation is 2.5. Approximately what percent of men are within 1 standard deviation of the mean height?
Wait, so the whole thing is 2.5? No?
Well, it says the standard deviation is 2.5 inches. Do you guys understand what they're asking there?
Oh, okay.
So here's the average right here. The standard deviation is 2.5. So if I add 2.5 to 70, where am I?
So you're like, you're almost as
72.
72.5, right? Which is right here, because this represents 73. And if I subtract 2.5 from 70,
67.5.
67.5, right? So they're asking approximately what percent of men are within 1 standard deviation of the mean height. That's this. That's all of this right here. So how would you answer the question?
Well,
Add them all together.
you use math.
We know
Okay.
45.
We know that this one plus that one, that was all about 45, wasn't it?
Yeah.
So you have to add this one, which is, what, 11? Maybe 12?
I take 13.
Getting closer to 12, so 45 plus 12. Come on, 45 plus 12. 57. And let's say this is 11 right here. 57 plus 11.
68.
So roughly 68% would be within one standard deviation? Okay? Alright. You guys do or do not have this picture in your book right here of the little fish?
No.
You don't have this picture? What kind of useless books do you have?
The one that you told us to grab.
Ooh, look at that. Nice. I know.
Hey, can I get this refill?
You can. They'll charge you 50 cents for a refill. Okay. You guys don't have a picture of this, so you're just going to have to look up here. Everybody look at the screen here. For a population of male European eels, I don't know what difference making them male is. I guess they're bigger. Or maybe they're smaller. I don't know. The mean body length and one positive, one negative shown below. Sketch a normal curve showing the eels at 1, 2, and 3 standard deviations from the... Ooh. Do you guys understand the question here? Oh, too big. How do I go back? No. I don't know what I'm doing. There we go. So this is the average. This is one standard deviation plus, then this is one minus standard deviation. You're supposed to sketch a normal curve with this. Okay? We've got to make a normal curve. What difference does the average have on a normal curve? I mean, what importance is that for a normal curve? Come on, you guys, think. Phones away. Think. What is the significance of the average on a normal curve? That's the highest spot, and what else is important about it? Where does it need to be? It needs to be right in the middle. So in the middle of our normal curve, how high is it? Look at the picture here. How high should it be? Okay. You guys following? Well, actually, let me go back and correct one thing. The height of the normal curve is actually the percentage. Have they told us anything about a percentage here? So the actual height isn't going to be that important. Let me just show you what they're talking about here. At least put this in your notes that the average is 15.7. You don't have to draw a picture of an eel unless you want to. But I want you to write in your notes that the average 15.7. Plus 1 standard deviation is 18.5. And minus 1 standard deviation is 12.9. So you need to have that in your notes. What did I say? 12.9 is minus 1 standard deviation. Ooh, here's a tricky question. What is the standard deviation? How do we know that?
Just the one of them.
Do you guys want to hear that? They've told us what plus 1 standard deviation is. It's 18.5. What's the difference between 15.7 and 18.5? 2 point.
Okay. So we need to know that.
Let's write that down with everything else that you wrote down. The standard deviation. .8. The standard deviation is 2.8. What is this? What am I saying when I write that down?
The mean.
What is the mean?
15.7 inch.
15.7.
Inches.
Correct. You guys with me? The standard deviation is 2.8 inches, and the average or the mean is 15.7 inches. Okay? So, I'm going to give you away the answer. If I show you this,
So,
should I or shouldn't I?
why are you trusting us?
Let me go back to this screen here. Yeah. What value should be right here?
The highest 15.
The mean, which is, okay, so let's start there. They didn't tell us anything about percentages, so we don't need to be concerned about the actual height. We can say the height is up here somewhere. That's fine. Now, if we're going to draw the normal curve, shouldn't it look something? Ooh, I messed that one up.
Wow.
Let's try that again. You guys think you can do better? Of course we can.
We're perfect.
There we go. That's pretty good right there, isn't it?
That's fine to the side.
Oh, I just messed it up.
Wow. So, teacher.
You still messing up.
Anyway, close it up.
Yeah, what kind of teacher are you?
Okay. What did I say about where the +1 standard deviation ought to be? Notes to the right. Wait. Is it right here, right here? Where is it?
Halfway.
It's about halfway in the curve, isn't it?
Yeah.
So right there would be +1 standard deviation, and right here would be -1 standard deviation. We know those values. What are those values?
18.5, 12 point.
So label that as 18.5 and label this as 12.9. So we're doing exactly what they asked. We're making a normal curve. We don't have to worry about the vertical height because they didn't tell us any kind of percentages. Is that what you're asking? If they had told us percentages, we would have to have some kind of an axis right here involving percentages, but they didn't tell us any of that, so we don't have to worry about it. Now we need to have a +2 standard deviation, so put a line here. We need to have a -2 standard deviation, so put a line there. And I should have written it down. What was it? Standard deviation was 2.8. So if we add 2.8 to 18.5, so this right here would be 21.3. What would this be over here? 10.1. Yeah, so that would be +2 standard deviation.
Do we go to 3 also?
Well, that's what I was going to ask. Does 2 standard deviations cover everything? What essentially covers everything? So we need a third one there. This would be 99.7% of the data.
Is there anything called a fourth deviation?
You could go out for it. Go as many as you want.
That'd be
24.1.
24.1?
Yeah. That one's going to be 7 point something.
7.3. So that's a normal curve. Okay, based on the data they gave us, the average is 15.5, +1 was 18.5, -1 is 12.9. From that, we can get all the other distances for standard deviation.
Okay. Did we get it right? Oh, theirs looks so much better than mine.
wow.
I'm jealous.
I'm jealous. I guess my Spark board ain't so smart.
Lost the user.
They cheated. Okay, we're just about done, you guys. Hang in here.
The smart board does exactly what it's told to do. It's the user's fault.
It's an unsmart user.
There's the magnifying glass.
It's called operator error.
Operator error.
Trevor, same thing.
Oh, so the magnifying glass is on wrong.
Okay, so we have this problem 3 here we're looking at. The heights of adult American males are approximately normally distributed with mean of 69.5. So you can see the picture here. This is the graph, the normal distribution that they've graphed for us. The average here is 69.5, and the standard deviation they say here is 2.5. So if you add 2.5 to 69.5, you're out to 72. If you subtract 2.5 from 69.5, you're down here at 67. So the question is, what percent of adult American males are between 67 inches and 74.5 inches tall? What percent of adult American males are between 67 inches and 74.5 inches. Well, 67, these right here represent all of the percentage of males below 67 inches, so we don't want any of that. So here's 67, here's 74.5. This represents the percentage of males taller than 74.5 inches. We don't want any of that. We want these percentages here. 34% are between 67 and 69.5. 34% are between 69.5 and 72. And 13.5% are between 72 inches and 74.5. So if we add up all these areas here, that would give us the percent of males between the heights of 67 inches and 74.5 inches. So we've got 34 plus 34 plus 13 and a half. That's 81.5%. So 81.5, roughly 82% of adult males are between the heights of 67 inches and 72 inches. Now, using this same normally distributed data here, if there are 2,000 adult males, about how many would you expect to be taller than 6 feet, or 72 inches? So, clear this out here. So 72 inches is right here. These represent all the percentage of adult males less than 72 inches. So we want this area, we want this area, and we want all the rest of it out there if there are any super tall people out there. So this is 13.5%. The third standard deviation here, the area was 2.35%. But then we have this little teeny area out here. So if you remember, within 3 standard deviations, so let me do all 3. Within 3 standard deviations, that was 99.7. So between here and here, we've covered 99.7% of the data. So that means outside of 3 standard deviations, this area out here and this area out here, those combined represent 0.3. So if you split that, this little area here, this would be 0.15. So if we take the 13.5%, the 2.35%, and the 0.15%, and add that up, well, 2.35 plus 0.15, that's 2.5, and we have 13.5. So if we take the 13.5 and add the 2.5, it's going to be 16. So 16% of the American adult males are taller than 72 inches. So what they're asking then, if you have 2,000 adult males you're looking at, how many of them are going to be taller than 6 feet? Well, 16% of the nation's average of the nation are taller than 72 inches. So of the 2,000, we would expect 16% of the 2,000 to be taller than 72 inches. So you would do 0.16 for 16% of the 2,000 males we're talking about. It's 0.16 multiplied by 2,000. So it's 320. We would expect of the 2,000, 320 of them to be taller than 72 inches. So take a look at page 37, the problem 3, got it. And we'll do this one together as well. So it's on page 37, the problem 3, got it. The scores of an Algebra 2 final are approximately normally distributed with a mean of 150 and a standard deviation of 15. First question is, what percentage of the students who took the test scored above 180? Well, they haven't given us any kind of graph to look at, so we're going to have to make our own. The average here is 150, that's the mean. And if we think about normally distributed data, standard deviation comes about halfway through the curve there. So the standard deviation is 15, so that would make this 165. That would make this 135. And then down here we would have 120. Up here we would have 180. What percentage of the students who took the test scored above 180? Remember, on the right side of the mean, this is 34%. This here is 13.5. Let's see, this is one standard deviation, two standard deviations. If we put a third standard deviation, this would be 195. So the little teeny area right there, and the third standard deviation, remember, was 2.35. And all of the area beyond 3 standard deviations here is 0.15% of the data. So anything above 180 would be, in this region right here, 2.35% plus 0.15%. That's 2.5%. So 2.5% of the students who took this test scored above 180. Now, part B here, if 250 students took the final exam, approximately how many scored above 135? Well, here's 135 right here. So all of these percentages here would have to be added together. 34 plus 34 plus 13.5 plus 2.35 plus 0.15. So this is just giving us the percentage here. So this is, let's see, 2.5 plus 13.5, that's 16. 16 plus 68. This is going to be 84%. So 84% of the students who took this test scored above 135. So we've got to figure out what 85%, so 0.84 of 135, or 0.84 of 250 students. So on the calculator, 0.84 multiplied by 250 is going to be 210. So of the 250 students that took the test, or if 250 took the final exam, 210 would score above 135. Now, you're going to love this. This really isn't that hard to do by hand. However, there is a nice feature of the calculator that will do all of this for you. You need to know 4 important numbers. So let me do a blank screen here. To use the calculator, you have to have a lower bound, you have to have an upper bound, you have to know the mean, and you have to know the standard deviation. So if you know all 4 of these things, you can use a calculator to calculate a percentage of people or whatever that fall within a range. So the last example, for example, the number of students that scored above, or the percentage of students that scored above 135. Well, if they're scoring above 135, the lower bound would have been 135. The upper bound, you really just have to put some big giant number in there, because let me go back. What was, let's see, 3 standard deviations was 195. So really this goes on forever and ever and ever, this line out here, but you know, for an upper bound, you could just do some big positive number like 1,000 or something like that. The average was, when they say the average was 150, and then the standard deviation was 15. So turn the calculator on. If you have a TI-84, or even if you have an 83, you find this feature in the same place, but how you use it is a little bit different depending on the model of your calculator. So first thing you hit is the second button, and then VARS. And then the second option down says normal CDF. This stands for normal cumulative distributive function. Anyway, this is the one you want, normal CDF, not normal PDF. So hit enter on normal CDF. And again, depending on how new or updated your calculator is, it might look a little bit different than this. But the lower bound is 135. We want to know the scores above 135, so that's the lower bound. The upper bound, really, all it said is above 135. If they had said something like, what's the percentage of students that score between 135 and 180, then 180 would have been your upper bound. But since they just said above 135, then you just throw out some real big positive number there. I just chose 1,000. This funky looking U, that's your mean or your average, so 150. And then the standard deviation, that's this little O, that was 15. And then you hit enter on paste. So you can see here it says 0.84. It's 84%. And if you remember a few moments ago, that's what we calculated here. The percentage of scores above 135 was, here it is right here, 84%. So rather than having to add up all of these by hand and figure out the area or the percentages, we can have a calculator do it for us. So if we consider a problem here, let's see, here it is. So it says here just a random question. Using a graphing calculator, calculate the percentage of adult American males that are between 63 inches and 76 inches. So we go back, second, VARS, normal CDF, and now they've given us both an upper and a lower bound. They want to see the percentage of males between 63, so that would be our lower bound. Upper bound would be 76, and it's the same. Let's see, actually no, here they're telling us the height of an adult American male is 69.5. The average height and the standard deviation was 2.5. Oh, by the way, I forgot to bring this up. If you don't have a TI-84 Plus with the new software, when you hit normal CDF, it's going to bring you to this screen here. And you have to type things in to the parenthesis. So the first number you type in here, you can see, is your lower bound. The next number you type in is your upper bound, and then comma, then you have your mean, or average right there, and then the last number you type in is your standard deviation, and then you hit enter. So it's saying roughly 99% of American adult American males are between 63 inches and 76 inches in height. So any one of the problems we've just done in the last few minutes could have been done on this calculator with this normal CDF feature. There's a bunch more practice problems here. So anyway, that's the lesson.